Hi guys, welcome to this page of the notes. What we're going to do is we're looking at three, right? We're looking at three product theorems. We're looking at the chord product theorem, the secant product theorem, and the secant tangent product theorem. On the previous page of the notes, we looked at the chord product theorem. Here on this page of the notes, we're going to look at the secant product theorem. But before we do that, what is a secant line? So, some definitions for you. Please be very, very careful. It will be easy to confuse secant lines and tangent lines, but they are two very different things. A secant line is a line that will intersect the circle at 2 points. Intersects the circle at 2 points. Please do not confuse that with a tangent line, which intersects the circle at 1 point, which we call the point of tangency, all right? So they're very, very different, but it might be easy to confuse the two. So please be very careful. Flashcards to help you memorize terms and definitions, Quizlet, something like that, whatever it takes to remember. Secant line intersects the circle at 2 points. Tangent line only intersects the circle at 1 point. Now, our theorem, the secant product theorem, is going to require you to know two different parts or two different segments of a secant line. There are secant segment. The secant segment is the part of the secant line, right, with at least 1 point on the circle. So I have two secant segments in this diagram down here. I have the secant segment. Oh, sorry, I don't want my highlighter pen. I have the secant segment AE, and I have the secant segment CE. Here's the reason that they're secant segments. They're secants because they intersect the circle at 2 points. They're segments because when I draw it from C to E, they're common endpoint, right? We talked about those circumscribed angles in the last section, right? Here, E is a circumscribed angle, right? I told you it was going to show up in this section. Here it is. These secant segments have a common endpoint at E, and E is that circumscribed angle. So, secant segments. Then there are what we call external secant segments. These are going to be the portions of that segment that are on the exterior of the circle. There are also two of these. I have the secant segment BE. That guy right there. BE is a secant segment. And then I have the secant segment DE, which is that guy right there. So first, a secant line. Secant line intersects the circle at 2 points. Then there's the secant segment, which is going to be the portion of a secant line, intersects the circle at 2 points, but they share a common endpoint. And then there'll be the external secant segments, which are just those portions of the secant lines outside of the circle. With that in mind, here we go. The secant product theorems. Actually, let me keep that color diagram there for you. Here's the way it works. Ton of words. That is actually not too terribly complicated. Here's the way it works. Again, I have my secant segment AE. There it is. Secant segment AE, just like I had up here, secant segment AE. What the theorem says is I'm going to take that segment AE. I'm going to multiply it by its external secant segment, in this case, BE. So I take the entire secant segment AE and its external secant segment BE, multiply them together. The theorem says that must be equal to the secant segment CE. The entire secant segment CE multiplied by its external secant segment DE. That's it. That's the theorem. Again, please notice it is multiplication, which means the order doesn't matter. Multiplication is commutative. AE times BE is exactly the same as BE times AE. So please don't think you're going to mess these problems up if you switch the order. You will not. Really, the idea here is just simply this. You need the entire secant segment multiplied by its external secant segment. All right, let's try some of these. I got several example problems for you right down here. Here we go. Once again, the geometry will help us set up the problem. From there, it's going to be algebra to solve, and this algebra will be slightly trickier than the algebra that we saw on the previous page, but you'll catch on quick. Here we go. I have two secant segments. I have the secant segment AC. So AC times its external BA has to be equal. My other secant segment is AE. And that has to be multiplied by its external AD. That's it, guys. That's the geometry. This is the secant product theorem. There it is, secant product theorem right there. The secant segment multiplied by its external secant segment has to be equal to your other secant segment multiplied by its external. Now it's plug and chug. We'll solve for the part that we don't know, but be careful. What is the length of AC? Well, here's what I've given you. I've given you each of these little segments. I tell you that AB is 5. I tell you that BC is X. How do I find the entire length? I have to add the two together. I have to add them together. So AC is actually X plus 5. This length right here, AC, is going to be whatever this guy is, X, plus whatever this guy is, 5. X plus 5. I multiply that by BA. Well, BA is 5. So multiply by 5. That all has to be equal to AE. AE. Oh, this one's easy. I gave you both of them. This part is 6. This piece is 6. So how do I find AE? Add them up. AE has to be 6 plus 6, which is 12, multiplied by AD, which is 6. Okay, here's why the algebra is slightly trickier than the ones that we did before. I have a product here, I have a polynomial here, multiplied by a constant. You will need to remember to distribute the constant through the polynomial. This is a big old distributive property. We wind up with 5x plus 25 is equal to 12 times 6, which of course is 72. Now the algebra gets a little bit simpler. Subtract the 25 to the other side. 5x is equal to 47. Unfortunately, 47 is not evenly divisible by 5. That's okay. We're going to wind up with a decimal. That decimal will be 9.4. So x is equal to 9.4. Let me write it right there so I can erase this. Again, every single one of these problems, you're more than likely going to wind up with a distributive property, right? Why? Because you're going to have to add together those two segments to get the entire secant segment, which will require you to set up some sort of polynomial, which you'll then have to distribute through. Still, not terribly tricky algebra. You did this a ton in Algebra 1. So again, we'll just practice it a few times here until you get comfortable with it. But watch out for that distributive property. With these kinds of problems, you'll probably be doing the distributive property in almost every single one of them. Anyway, we get 9.4. Let's go ahead and try another one together here. Let me erase this. And I'll do the next one right in there as well. Here we go. So here's my next one. Okay, they want me to find x. So first thing I'm going to do is set up my geometry. The geometry says that SP times RP. SP times RP has to be equal to UP times TP. UP times TP. All right, that's the geometry. Now it's algebra. What is SP? Well, it's going to be 8 plus 6, which will give you, 8 plus 6. 8 plus 6, which will be 14. So SP is 14. multiplied by RP, which is 6. That has to be equal to UP. All right, now, careful. UP, all right, I have two segments. I have this segment X, this segment, which is 7. I have to add those together. So you wind up with X plus 7. But then that's going to be multiplied by TP, which is 7 times 7. Okay, so there we go. Distribute, solve for X. All right, so 14 times 6 is going to be 84. I distribute the 7, I wind up with 7x plus 49. Subtract the 49 to the other side, 7x is going to be equal to 35, and that works out nice. 35 divided by 7 is going to be 5. So we get x is equal to 5, and once again, just like in the last one, we wind up with a polynomial that I have to distribute something through in order to do the algebra properly. Okay, let's keep going. I got a couple more for you here. Again, practice makes perfect, so we're going to keep practicing these until we get good at them. I'll erase that so that I have space so I'm not squeezing on you guys. And here we go. I'll slide on up. All right, next. Okay, my next one is going to be PR times PQ. So PR times PQ has to be equal PT times PS. PT times PS. Again, it's multiplication. It doesn't matter what order you do those in. It's going to come out to be the same either way. Okay, here we go. I have PR, which is going to be 5 plus a 5.4. So how about 10.4? 10.4, which is going to get multiplied by PQ, which is 5. That all has to be equal to, what do you get for PT? Right, PT is this segment, which is 4, plus this segment, which is x. So, yeah, x plus 4. Once again, we get this polynomial, which I will then have to, right, PS is 4, distribute the 4 through the parentheses. Don't forget to distribute. All right, here we go. 10.4 times 5 actually comes out to be nice. It's going to be 52. I get 4x plus 16. Subtract the 16 to the other side. 52 minus 16 gives me 36. And 36 divided by 4 is 9. So we get a 9 for x. X is 9. Let's do it again. Again, the more practice we get, the better at these we're going to get. HL. So HL multiplied by JL has to be equal to NL multiplied by ML. Okay, here we go. 4 and 6. 4 plus 6 is 10, so I know HL is 10. I'm going to multiply that by JL, which is 6. All right, careful now. NL. I actually give you 3 different segments. I tell you NP is X, PM is X, and then ML is 5. You have to add all of those together so you have X plus 5. So X plus 5 multiplied by ML, which is 5. Okay, 10 times 6 is 60. Equals, careful, x plus x, it's 2x. Multiply by 5, don't forget to distribute. I get 60 is equal to 10x plus 25, and here we go. Subtract the 25 to the other side. 10x is going to be equal to 35. Divide by 10, and x is going to be equal to 3.5. So I get this guy right here is 3.5. I get this guy right here is 3.5. So if I were to ask you to find NM, right? What is that segment NM? Well, you'd have to add these together, which of course would get you 7. Now, I just asked you to find the value of x in the directions, which you did. You found x. But make sure that you read directions carefully. On a quiz or a test, I could certainly give you one of these, and instead of in the directions saying find the value of x, I would say in the directions find mn, which is going to require you to find the value of x, but then don't make the mistake of thinking, oh, I found x, I'm done. Well, careful, I may ask you to find something else once you know the value of x. So please make sure that you read the directions carefully and then give me the answer that I'm looking for. So now we've looked at the chord product theorem, the secant product theorem. On the next page of the notes, we'll look at the secant tangent product theorem. I'll meet you guys there.